Yes, student, today we are doing question number first of exercise 8.2. This exercise is based on midpoint theorem. So let us read the question. ABCD is a quadrilateral in which P, Q, R and S are the midpoints of the side AB, BC, CD and DA. AC is a diagonal. Show that SR parallel to AC and SR equal to half of AC. Number second, PQ equal to SR, and number third, PQRS is a parallelogram. So student, first of all we'll see the figure. We have a quadrilateral ABCD. So this is the figure. We have a quadrilateral ABCD. P, Q, R, S are the P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD, and S is the midpoint of AD. When we join all of them, we get P, Q, R, S. At the last, we have to prove P, Q, R, S is a parallelogram. We have to prove this is a parallelogram. And one diagonal is also given, and that is AC is the diagonal. Now we have to use the midpoint theorem. So taking this diagonal, if we take this diagonal, we have the triangle ACD, and in this triangle we have S as the midpoint of side AD and R as the midpoint of side CD. So we can use the midpoint theorem. According to midpoint theorem, the line segment joining the midpoint of two sides of a triangle is parallel to the third side. It means SR is parallel to AC and is equal to half of it, or we can also say SR is equal to half of AC. So from here we will get the first part which we have to prove. For the second part we have to prove PQ equal to SR. So for that we have to take the another triangle which is below the diagonal AC. Here also we can say P and Q are the midpoint. So by applying the midpoint theorem, PQ is parallel to AC and PQ is equal to half of AC. Using the concept of half of AC from first and second, we will get the second condition. And for the third, PQRS is a parallelogram. If any one pair of quadrilateral is equal and parallel, then we can say that quadrilateral is a parallelogram. So we're going to apply that. So let us start the solution. In triangle ACD, S and R are midpoints. We have to mention the side. Midpoint of S is the midpoint of side AD and R is the midpoint of side CD. Therefore, by midpoint theorem, we will get SR parallel to AC and SR equal to half of AC. Let this be equation number first, and underline it because this is the first part which we have to prove. Also, we're going to take the another triangle. In triangle ABC, P and Q are midpoints of side. P is the midpoint of AB and Q is the midpoint of BC. Therefore, again by midpoint theorem, we will get the condition that PQ is parallel to AC and PQ is equal to half of AC. Equation number second. Now since we have to prove in the second part that both of them are equal, so from first and second we're going to take both the condition from equation first and equation second. Since SR is parallel to AC and PQ is parallel to AC, both of them are parallel to the same line. So we can say both of them are parallel to each other. So from equation first and second we will get SR parallel to PQ. And SR is equal to half of AC PQ is equal to half of AC. Again, both of them are equal to the same thing, that is half of AC. So we can say SR is equal to PQ. SR equal to PQ, or PQ equal to SR. We are writing in the correct form. Underline it because in the second portion which we have to prove, it is given PQ is equal to SR. Now let this condition be the third condition. Since in quadrilateral PQRS, PQ parallel to SR and PQ equal to SR from equation third, therefore PQRS is a parallelogram. This is the symbol of parallelogram. We have to give the reason because a quadrilateral in which one pair of opposite side is equal and parallel is a parallelogram. Again, what is the reason? Because a quadrilateral in which one pair of opposite side is equal and parallel is a parallelogram. Thank you.